This is a photoelectric effective experiment. Light source filter, so we've got the right colour, or we can look at different colours, goes onto a metal plate. Right, so with a particular filter in place, i.e. particular colour, students gradually increase the voltage. This is the voltage here. So what happens is light hits the metal plate, electrons jump across to there, and they try and make a circuit. And we apply a voltage going the other way to stop them from trying to jump across there from being ejected. So what the students have done is they measure the current, so they measure the number of electrons, and they gradually increase this voltage, and eventually the current goes down to 0. Explain why, for 2 marks, the current drops to 0 at point X. Right, so this needs 2 dot points. Well, the key is first that the electrons that jump across or are ejected from this plate don't all come out at the same speed. They have a range of energies. So here we've got a lot of electrons jumped out. As we increase the voltage to say here, there's going to be less electrons that make it out. And here less electrons, and here less electrons. And at this point X is where no more electrons. So that voltage represents the voltage needed to stop the most energetic electrons. That are emitted. Alright, that was 5, so question 6. Alright, they used 5 different colours and measure the stopping voltages for those colours. And they want us to plot a graph of that. Cool. That's just, you can use your graphing skills. The first one's at 4.5 by 10 to the 14, so 4.5 is maybe 4.2.4.5, and it is 1.3, 1.2.3. Next one is at 5 and 1.5, so here is 5, 1.2.4.5. Next one is 6.1 and 2. 6.1 up here, and 2 would be here. Next one is 2.5 and 6.9. So 6.9 is probably going to be here 7. That'll be here. And it was 2.5, so there's 2, 2.2, 2.4, 2.5. And the last one is 2.8 and 7.6, so 7 here, 0.2, 4, 6. And I get it at 2.8. It's going to be about here. Draw a line of best fit. So you get your ruler, which I don't really have on this pad, so you're going to have a ruler. It doesn't go through every line, it goes through the middle of the line. So here's my line of best fit. Maybe more like this. Keep extending it down. Again, you're using a ruler. Not naughty like me, not using a ruler. Alright, so what I'm going to do is I'm going to cut and paste this for the next question. There's my selector. And I want to copy that, and then open the next question. Yeah, I'll save that. Question 7 and 8. So here's my graph, and I'm going to paste that graph on top of that one. There we go. Alright, question 7. From your graph, what value of h Planck's constant would the students have obtained? Show your working. So when we're doing these, the gradient is Planck's constant. Gradient equals h, which equals rise over run. So you just got to pick a few points to get the rise over run. What am I going to pick? I'm going to pick that it goes through 2 here, and that it goes through 4 and 1 here. My 2 points I'm going to pick. So we've got rise over run. It rises by 1 electron volt, and the run it goes for from here to here, it goes 2, because it goes from 4 minus 2, 2 by 10 to the 14. And that equals 0.5 by 10 to the 14, which equals minus 14, 5 by 10 to the minus 15. And that's the units they wanted it in. From your graph, what's the longest wavelength that will cause an electron to be emitted? So that's at this point here. So the frequency of that is 2 by 10 to the 14. We've got lambda equals c over f, which equals 3 by 10 to the 8, divided by 2 by 10 to the 14. This equals 1.5 by 10 to the minus 6, and that equals 1500 by 10 to the minus 9, which equals 1500 nanometers. 1500 nanometers. I think there's one more question in this set. Yep, outline the conclusions about the nature of light that Einstein made from the observations of the photoelectric experiments. Okay, well, so the main observation that we're going to write about is it was observed that frequency of light and not the intensity contributed or changed the max kinetic energy of electrons. That's the observation, and then the explanation about this that Einstein made. Einstein explained this by postulating, it's a good word, postulating that light occurs in packets called photons with energy equal to hf, and each electron could absorb one photon. Done.